Coulombs Law. Coulombs Law tells us that two charged objects exhibit a non-contact force of attraction or repulsion on each other due to their charges and proximity to one another. We write Coulombs Law as the force of attraction or repulsion is equal to K times the absolute value of charge 1 times charge 2 divided by the distance between the two charges squared. Now K is known as Coulomb's constant, and it has a value of 9 times 10 to the 9 Newton meters squared divided by coulombs squared. Now Fe, the force of attraction or repulsion between two charged objects, is measured in newtons, N, and Q, which is the charge, is measured in coulombs, capital C. Now an electron has a charge of negative 1.6 times 10 to the minus 19 coulombs. We call this the elementary charge, and we use that as a reference. Also a proton, which is positively charged, is positive 1.6 times 10 to the minus 19 coulombs. Notice that the magnitudes are the same, but the signs are different. This is negative and this is positive. That's something that you learned in chemistry. Now, like charges repel. We know that. So if you have two positively charged particles, Q1 and Q2, they apply a force equal and opposite from one another. So this would be the free body diagram of the force of Q2 on Q1, and this would be the free body diagram of Q1 on Q2. Now remember that these two forces are paired forces, and according to Newton's third law, the force of 1 on 2 is equal to negative force of 2 on 1. Now the same thing would apply if we had two negatively charged particles. They would apply a force which would be a repulsion force on one another, and they would try to push each other apart. Now opposite charges attract. So if we had a positive charge and a negative charge, there would be an attractive pull to one another. Now the formula, we see that Q1 and Q2 each affect the force of attraction or repulsion on one another. So Q1 is directly, the value of Q1 is directly proportional to the force between Q1 and Q2, and the charge of Q2 is directly related to the force between the two charged particles. So for example, if you double Q1 and triple Q2, overall the effect would be that the force would increase by a factor of 6, assuming that the distance remains the same. Now, the force and resistance follow what's called an inverse square relationship. So the force of attraction or repulsion is proportional to 1 over r squared. So for example, if we triple r, that will reduce the force of attraction or repulsion by 9. So the new force experienced by the two charged particles would be 1/9 of the old force with the original distance between the two particles. Now we can take this formula right here, that relationship, it's really a relationship, and rearrange it to read r squared is proportional to 1 over the force. And we can further change that to r is proportional to 1 over the square root of the force. So for example, if we quadruple Fe, that will reduce r by 1 over the square root of 4, which is reduced to 1/2. So the new radius in that case would be 1/2 of the old radius. So finally, the relationship in Coulomb's law are similar to Newton's law of gravity, except it applies to charges, not mass, and the force is attractive or repulsive. And the force is much stronger, the electrostatic force is a much stronger force than the force of gravity.